This question belongs to the topic theory of machines from the subtopic mechanisms. In a crank slider mechanism, the length of the crank and connecting rod are 100 mm and 100 mm and 160 mm respectively. The crank is rotating with an angular velocity of 10 radian per second counterclockwise. The magnitude of linear velocity of the piston at that instant corresponding to the configuration shown in figure is dash. Okay. So here is the diagram given to you. Okay, so crank is at 90 degrees, this is 100 mm, this is 160 mm, so it is rotating with an angular velocity of 10 radians per second, and he is asking you to compute what is the velocity of the piston. Okay, now yes, you can solve this problem by using a direct formula also, or by Kennedy's theorem also you can apply. This is a special case also. So here velocity of the piston, here is asking you to calculate velocity of the piston is equals to, that is r omega into sine 2 theta by 2n. So here r is given as 100 mm, that is 0.1, into omega is 10 radian per second, into sine 90 into sine 180 by 2 into L by R. N is equals to L by R, that is ratio of connecting rod to length of the crank, that is 160 by 100. Okay, sorry, this will be 160 by 100, so this will be a zero term, so this will be 1 meter per second will be the velocity of the piston. Or else here, if you look at this problem, okay, these two here, the piston, the sliding of the piston, if I want to convert this into a revolute joint, instead of sliding pair, if I want to convert this into revolute joint, this can be converted by placing with a link of infinite length. Okay, so now here if you see, these two links are parallel. If you see, these two links are parallel. When these two links are parallel, the velocity of the coupler link will be zero. Velocity of this link will be zero. So which means I can do one thing, that is V of crank, velocity of crank is directly equal to velocity of piston. Okay, velocity of crank is directly equal to velocity of piston. Or else if you try to plot the instantaneous center for this, let us this to be as 1 2 2 3 3 4 and 4 1. These are the instantaneous centers. And 4 1 will be also here present here. 4 1 will be also present here. So now as per the Kennedy's theorem, here if you see, this will be 1 2 3 and 4. If I want to locate 1 3, that has to be with 1 2 and 2 3. 1 2 and 2 3, this is the line. 1 2 and 2 3, this is the line, and 1 4 and 3 4, 1 4 and 3 4, this is the line. So definitely I13 will be at infinite. So from this I can say that I13 will be at infinite. Okay, I13 will be at infinite. When I13 is at infinite, so velocity of this coupler link will be zero, and this equation gets satisfied. Okay, so now I can write it as, that is r into omega of the crank is equals to velocity of the piston. Okay, so which is directly equal to, velocity of the piston is equals to 1 meter per second. Okay, so you can use this method or you can go for this method. Okay, when I13 is infinity, omega of this 3 will become 0. Okay, right. So this is the end of the answer. This question belongs to the topic theory of machines from the subtopic gear trains. A gear train shown in figure consists of gears P, Q, R and S. Gear Q and gear R are mounted on the same shaft. All the gears are mounted on the parallel shaft. The number of teeth of P, Q, R and S are 24, 45, 30 and 18 respectively. Gear P is rotating at 400 rpm. The speed of gear S is dash. So here it is given number of teeth on P is equals to 24, number of teeth on P is equals to 24, number of teeth on P is 24, number of teeth on Q is equals to 45, number of teeth on Q is equals to 45, number of teeth on R is equals to 30, number of teeth on S is equals to 80. Okay, here R is not meshing with any of the gears, so R is here the function of R is not having any significance. Okay, later it may be taken for different applications, but as of the question, R is not into use. Now gear P, speed of P is given as 400 rpm. Speed of P is given as 400 rpm. So now P is meshing with Q, Q is meshing with S. So the pitch line velocities for P, Q and S will be same. The pitch line velocities for P, Q and S will be same. That is NPTP. NPTP is equals to NQ, that is VP is equals to VQ is equals to VS. That is V is a function of pi d, diameter and rotational speed. Here V is proportional to product of diameter and rotational speed. Instead of diameter, I am replacing that with teeth. NPTP is equals to NQTQ is equals to TS NS. Okay, so now I can I need to calculate the velocity of the gear S, so I can use this relation, that is NS is equals to NP. NP is 400, NP is 400 and NS is equals to NPTP by TS. So this is equal to 400 into TP is given as 24. TP is given as 24, TS is given as 80, so this will be approximately 81s and 85s. 5 into 24 is 120 rpm. Okay, so here this is the 120 is the answer. This is the end of the answer. This question belongs to the topic theory of machines from the subtopic balancing of masses. Three masses are connected to a rotating shaft supported on the bearings A and B as shown in figure. The system is in the space where the gravitational effect is absent. Neglect the mass of the shaft and the rods. Connecting to the masses for M equal to 10 kg, M1 equal to 10 kg, M2 equal to 5 kg, M3 equal to 2.5 kg, and for shaft angular speed of 1000 radians per second. The magnitude of reaction in newtons at the location B is dash. Okay, this is the bearing A and B. This is a shaft supported with the rotating masses. Okay, now if you see, all the masses are being connected to a single point with respect to plane, and their location on the shaft is also shown to you. So here this is 0.1 meters and this is a 0.1 meters. So now here I can say that this is a case of symmetrically loading. Okay, this diagram, with respect to this diagram, I can say that it is a symmetrical loading. Okay, this is a symmetrical loading condition. And now here this problem or this concept belongs to the topic of balancing of masses, but this is from the balancing of masses in the single plane. Okay, balancing of the masses in the single plane. When the masses are balancing in the single plane, all the forces, all the centrifugal forces exerted due to the rotation of the masses will be concurrent. All the centrifugal forces that is exerted due to rotation of the mass will be concurrent. Okay, will be concurrent. There will be no rotation. The shaft will be, yes, due to these two bearing reaction and due to this force, the shaft may undergo rotation, but only due to mass, there will be only a reaction force exerted. Okay, so now this is similar to like calculating the resultant force when you have concurrent system of forces. So here, since all the masses are having same angular velocity, so I can write Fx is equals to, that is force due to force all these masses having. So I am trying to resolve these two forces in x and y directions, and then I am computing the resultant of that. Okay, so sigma Fx is equals to, that is m1 r1 omega is common for all, m1 r1 cos theta 1 plus m2 r2 cos theta 2 plus m3 r3 cos theta 3. This is the x component, okay. So here this is theta 1 equal to 0 degrees, this is theta 2, okay. This is theta 3 will be measured from the 1 only, this is theta 3, okay. This is theta 3, right. So now I can write this as m1 is given as 10 kg, m2 is 5, m3 is 2.5. Similarly, R1, R2, R3 are given to you, and omega is given to you. This I can multiply with omega square, okay. So this is m1 is 10 kg, 10 into the radius is 0.1, 10 into 0.1 into cos 0 is 1, and next is m2 is 5 into 0.2 into cos of the angle subtended between them is 120 degrees, cos of 120 degrees, okay. And the third angle will be m3 will be m3 is 2.5 into 0.4 into cos 240 degrees, okay. So now this will be equal to 10 into 0.1 into 1 is 1, and this will be 5 into 0.2 is 10, that is 0.1. 1 into cos 120 is 1 by 2, cos 120 is minus 1 by 2, this is minus 0.5, this is minus 0.5, and this is 2.5 into 0.4 is that is 1, and cos 240 is minus 0.5, so this is minus 0.5. This Fx is equals to 0, sigma Fx is equals to 0. Similarly sigma Fy I am doing, here it will be, this cos will be replaced by sine in case of y component. If you are solving for y component, so this will be m1 r1 sine theta 1 plus so on and up to m3 r3 sine theta 3, okay, into omega square, okay. So here it will be multiplied with omega square, but anyway the result is 0, so omega square will not have any significance here. So here I am writing, this is m1 is 10 into 5 into sine 0, 10 into 5 into sine 0. Next is m2 is 5 into 0.2 into sine 120 plus 2.5 into 0.4 into sine 240, okay. So this value will be anyway 0, this will be 5 into 0.2 is 1 into sine 120 is root 3 by 2, and sine 240 is minus root 3 by 2, 2.5 into 0.4 is 1 only once again, so minus root 3 by 2, so this will be 0. Sigma Fx and Fy are 0, sigma Fx and Fy are 0. The resultant will be 0. Resultant force will be equal to 0, and the reactions when the resultant is 0, the reaction at A and B, reaction at A and reaction at B will be equal to 0 newtons, okay. Reaction at A and B will be equal to 0 newtons. And now you will find this application identical, or you will find the same identical application in the ceiling fan, where the angle subtended between the blades of the ceiling fan is 120 degrees, okay, is 120 degrees. This is identical to that, and even you will find the same kind of application in the toys also, okay. This is the end of the answer. This question belongs to the topic theory of machines from the subtopic mechanisms. Block 2 slides outward on the link 1 at a uniform velocity of 6 meter per second as shown in figure. Link 1 is rotating at a constant angular velocity of 20 radian per second counterclockwise. the magnitude of total acceleration of the point P on the block with respect to fixed point O is dash. Okay, this question belongs to the topic from the subtopic, that is Coriolis component of acceleration. Here the link is given to you. On this link, block block is moving with a velocity of 6 meter per second, velocity of 6 meter per second, and this link is rotating in anti-clockwise direction. Omega is given to you, and the length of the link is given as 100 mm. Okay, so as of here, as of this link, this is rotating with a constant angular velocity, which means the tangential acceleration will be 0. Okay, and acceleration of the piston is not mentioned, but it is mentioned that yes, it is moving with uniform velocity, means acceleration of the piston is 0. So now Coriolis component A will be, a radial component will be r omega square, that is radius of the link is given as 0.1 into angular velocity of the link is given as 20. Angular velocity of the link is given as 20 square, that is 400 into 0.1 is 40 meter per second square, 40 meter per second square, A radial, and next will be A Coriolis. A Coriolis will be 2V omega, 2 into velocity of the piston. Velocity of the piston is given as 6 meter per second into omega is given as 20 radian per second. So this will be approximately equal to 2 into 6, 120, 12 into, that is 12 into 20 is 240 meter per second square. Okay, meter per second square. So A resultant acceleration will be equal to A radial square plus A Coriolis square root over, okay, this is 40 square plus 240 square. So approximately you will get this answer as 243.11 meter per second square. Okay, this is the end of the answer. This question belongs to the topic free vibrations. From the subtopic free vibrations, a mass m is attached to two identical springs having spring constant k as shown in figure. The natural frequency omega of the single degree freedom system is dash. Okay, here both the springs are arranged in parallel combination. So k is equals to 2k. Okay, and the governing equation for the free vibrations, free undamped vibrations, is x double dot plus k by m x equal to 0, or this is x double dot plus omega n square x equal to 0. This is the governing equation of the free undamped vibrations. So since here damper is absent, so this should be of this form. So here equivalent stiffness is 2k, and omega n will be equal to equivalent stiffness by m, that is equal to root over 2k by m. Okay, which is the option A, is the end of the answer. This question belongs to the topic vibrations. From the subtopic free vibrations, the radius of the gyration of the compound pendulum about the point of suspension is 100 mm. The distance between the point of suspension and the center of mass is 250 mm. Considering acceleration due to gravity as 9.81 meter per second square, the natural frequency of the compound pendulum is dash. Okay, here the radius of gyration is given to you as 100 mm, and the distance from the point of suspension is given as 250 mm, and acceleration due to gravity is given to you. So now the natural frequency of the compound pendulum, that is equal to omega n is equals to root over mgl by I. Okay, this is in case of compound pendulum. So here it will be equal to, m is not known, m into 9.81 into length is 250 or 2.25 divided by I is mk square. I is equals to mk square. I is equals to mk square. M into radius is 0.1 whole square. So now upon solving this omega n, you will get it as 15.66 radian per second square. Okay, is the end of the answer.